Fowler, and today we're going to be going over the West African Examination Senior Certificate Examination. We're going to be moving over to the section that has to do with measurement. In this section, we're going to be covering several objectives. The first objective we're going to cover will have to do with finding the length and perimeters, and under that would be we have to find the length and distances using the Pythagorean theorem, using the laws of sines, cosines, and tangents. And the second objective, which we have already stated over here. We also need to know the formulas for finding the circumference of a circle and the formulas for finding an arc length of the circle, which is a portion of the circumference. In this formula over here, for the circumference of the circle, we have two forms. One is when we use the radius, and the other one is when we use the diameter. Likewise, when we find an arc length, one of the formula is when we use the radius, and in the other formula is when we use the diameter. A in these formulas represent the measurement of the central angle. Then we also need to know the formulas for finding the distance between 2 points, say P1 and P2, with coordinate x1, y1, x2, y2. So we have the distance formula, and we also have the midpoint formula. Then when it comes to the Pythagorean theorem relates to a right triangle. What is a right triangle? A right triangle is a triangle with one angle measuring exactly 90 degrees. So here's a right triangle we have here. The two sides of this triangle, we call them the legs. And we call the longer side here hypotenuse. So we can, in a right triangle, we can represent our two legs with letters A, the length of our two legs to be AB, and we usually represent the length of the hypotenuse as C. Based on this, we have that relationship that is square, the sum of the squares of the length of the leg is equal to the square of the hypotenuse. Then we also have what we call trigonometric ratios, again appertaining to right triangle. So if I have my right angle over here, and we usually will label our angle uppercase C, and the side opposite that, our hypotenuse are lowercase c. The other two sides, it really doesn't matter. I label this A, and the one opposite it, we label it small a, and we label this angle B, and the side opposite is small b. Based on this representation, we have those three trigonometric ratios. For the sine, we say the sine is equal to the side opposite. The sine of an angle is equal to the side opposite the angle divided by the hypotenuse. The cosine of an angle, and this should be an A over here. We say the cosine of an angle is equal to the side adjacent to the angle. In this case, the side adjacent to angle A is B divided by the hypotenuse. And we say the tangent of the angle is the ratio of the opposite side to the adjacent side. Okay. Okay, then we have the concept that has to do with special right triangles. We have two sets of special right triangle. One set of right triangle we call the right isosceles triangle. So isosceles, so at least two sides are equal. Right, so one angle is 90 degrees. The two sides that are equal will be the two legs, and the other sides are hypotenuse. Whenever we have a situation like this, because the two sides are equal, the angles opposite them must be equal. So we have a situation of a 45, 45, 90 degree triangle. And if we were to even apply the Pythagorean theorem, you're going to see that the length of the hypotenuse is given by the product of the length of the side and the square root of 2. So now, then another case, the last case we have is the one for a right scalene triangle. Well, all the sides here, we have scalene, so all the sides are not equal. The sides are not equal. One angle is right because we say right scalene. And we're saying that one angle is going to be 30 degrees, one is 60, and one is 90. So the angle opposite the shortest side would be 30 degrees. So the shortest side appears to be this. So this is going to be 30, and this is going to be 60. So the shortest side is opposite the smallest angle, is S. The hypotenuse is given by the product of 2 and the length of the shortest side. And the longer side here will be S times the square root of what? 3. Now, which one of these concepts do we use in a given problem? Do we use the Pythagorean theorem? Do we use special right triangle relationship? Do we use trigonometric relationship? It's based on the information that is presented in the problem, which we're going to see in the next set of problems we're going to do. Let's go ahead now and try the problem. So in the first problem we have here, and I will move over to this end, it says that an acute angle of a right triangle. So I'm going to be drawing and representing as I move. I see here that we have an acute angle of a right triangle. So that means I have a right triangle. I see that the acute angle is 36 degrees. It doesn't matter. I'm going to put the 36 degrees over here. And the hypotenuse here is 5 feet. So this is the hypotenuse. I'm going to put 5 here. And I want us to find the length of the leg opposite the other acute angle. So the other acute angle is this angle right here. The leg opposite it would be this leg. And they want us to find that the length of that leg. Now, do we need to know the measurement of that angle? Absolutely not. Can we find it? Yes. Obviously, that's very simple. This angle and that angle will be complementary. So if we do 90 minus 36, that's going to be 54. But we do not actually need it to solve our problem. So now, we cannot use the Pythagorean theorem in this problem because we only know the measurement of one side. We cannot use the special right triangle because none of the angles in here is of 45 or 30 or 60 degrees. So we can see clearly in this problem that we have to use the trigonometric ratios. So which one of the trigonometric ratios do we use? Sine, cosine, or tangent? Let's not guess. Let's list the information we have given to us in this problem. So let's write given. So I'll use A for my angle. So my angle A here is 36 degrees. Now, in a trigonometric relationship, we have 3 things that we're going to be concerned with. Opposite side to A, adjacent side to A, and the hypotenuse of the triangle. Well, the hypotenuse of this triangle is 5 feet. I have 5 feet. Now, what is the side opposite A? So if A is here, this side right here is opposite A. Now, I'm not interested in knowing that side, so I don't have to worry about it. So if this is the side opposite A, and if this is the adjacent hypotenuse, then X must be the adjacent. So in this problem, then, in effect, I do not need any information about the opposite. So now, the question I have to answer is, which one of the 3 trigonometric ratios connects the angle, the hypotenuse, and the adjacent side? If we recall correctly, that was cosine. So let's write then that the cosine of the angle, which is 36 degrees, is equal to the ratio of the adjacent side, x, to the hypotenuse. So if we were to put a 1 under here and cross multiply, we have x would be equal to full cosine of what? 36 degrees. And if you have a calculator, you can plug it in. Make sure that your calculator has already been programmed in degrees and not radians. And so we're going to have the cosine to be approximately equal to 4.05 feet. So sorry, the length of that side will be approximately 4.05 feet. Let's move to the next problem now on this section. So problem 2. So again, we're going to proceed by listing the information that is important to us in this problem. So 1, we are talking about the hypotenuse of a right triangle. So that means first thing we have a right triangle. Let's make a sketch of that right triangle. Let's mark the right angle. And the hypotenuse here, we are told, is 4 centimeters. That's the side opposite the 90-degree angle. And the length of one leg, which one of the leg, it doesn't matter, but one leg is 2 centimeters. I will just put the 2 centimeters right here. Find the length of the other leg. So here's the case. We have the length of two sides and one side is missing. So obviously, the best approach to solving this problem, or perhaps the most realistic approach to solving this problem, is using the Pythagorean theorem, which says that, look, the sum of the square of the legs is equal to the square of the hypotenuse. So we know one leg, we do not know one leg, so I put x squared. The other leg is 2 centimeters, so I have 2 squared equals to the hypotenuse square, which is 4 squared. And so now I have x squared is equal to x squared I have x squared Now let's move on to the third problem here. It says that the length of the leg of a right isosceles. So right and then isosceles triangle. So let's draw it. Let's make a sketch of that. So it has to be an isosceles triangle. So the two legs has to be equal. So it will be SS. And we have a 90 degree because it's a right triangle. Now this problem is saying that the length of one leg is 5. So this leg is 5. We know that automatically the other leg is going to be 5. But that's not what they want us to find in this problem. They want us to find this side, the hypotenuse. What's going to be the hypotenuse? Well, this is a case of a 45, 45, 90 triangle. Because if it is right isosceles, these two angles will be equal. So we have a case of 45, 45, 90 triangle. And we have that relationship that the two sides opposite the 45 degrees will be both S. And so in this case, 5, 5, that's the length of one leg, is 5 feet. So the 5 feet, so the other one has to be 5 feet. And the one opposite the 90 degree will be S square root of 5. So in this case, it's going to be, S square root of 2. So in this case, our S is 5, so it's going to be 5 square root of what? 2. So that's our answer for this problem, 5 square root of 2. Very easy, very simple, just have to know the rules. Now let's go to problem number 4. So it says that the ratio of the length of a rectangle to its width is 7/2. Now I'm going to move over and begin my representation just as it is stated. The ratio of what? Length of a rectangle to its width. So let's write the ratio. The ratio is going to be length to what? Width. So we have that fraction is 7 to 2. Right? So that's the ratio. So one of the things we can do in this problem is to represent the width in terms of the length and the length in terms of the width. But because in this problem we want to find a measure of the width, so the best thing is to do is to solve this proportion for the width. So we're going to cross multiply. So we have 2L equals to what? 7W. And to solve for the width, we're going to divide both sides by 7, both sides by 7. So the width, the best thing to solve for here will be the length. Let's solve for the length. So in that case, we will only have the width in our problem. So we have 2L is equal to what? 7W. We divide both sides by 2. Divide both sides by 2. So the length is actually equal to 3.5 of the width. Now, we've been given the perimeter here to be 288 feet. So let's write a formula for the perimeter of a rectangle. It's P equals to 2L plus 2W. We know the perimeter is 288, so I'm going to substitute 288 in the place of P. And I'm going to write 2 The length is given here in terms of W. So that length is 3.5 W plus 2 times what? W. So now we can see that our problem only has W in it, so we have one equation, one unknown that we can easily solve. So we're going to have 288 equals to 2 times 3.5, that's going to be 7W plus 2W. So that's going to give me basically what? 9W equals to 288 divided by 9. Let's see what this gives us. 9 into 28 is 3 times 9 is 27. So it's 3, and 3 into 18 will be 2. So our answer will be 32 feet. So the width is going to be 32 feet. All right? So let's move to another example, number 5. So in this one, it says calculate the perimeter of a quadrant of a circle with radius 10.5 centimeters. So what are we talking about over here? So let's do this. Let's just put it over like this. So let's draw a circle, kind of sketch a circle here. So what is referred to a quadrant would be just right here. That's a quadrant, and this is actually 1/4 of a circle. And basically, that's going to be approximate. That's going to be basically 90 degrees, given that the circle is 360 degrees, and 1/4 of 360 would be 90. Good. Now, so we have those information. Now, so we should calculate the perimeter of the quadrant. So that means they want us to find this arc length. That's another way of saying find the arc length of this. Well, we already learned the formula for the arc length. So let's call this arc length S. We say S would be equal to the measure of the central angle, in this case, which is what? 90 over what? 360. And we already didn't have to do that. Times the formula for the circumference, the part of the circumference, which is going to be 2 times pi times the radius, which is 10.5. So we can, the first thing is to see here that basically what we have is 2 times 3.14 times 10.5. I'm going to put this in parentheses like that so that we're not confuse the decimal point. Times 2 divided by, well, 90 over 360 is just 1/4 divided by 4. So let's do our calculation and then have our answer. So basically what we're going to have will be 2 times 3.14 times 10.5 divided by 4. And that will give us approximately 16.5. So approximately 16.5 centimeters. Now let's move on to the next one, which is example number 6. It says the vertices of a rectangle have coordinates given below. Find the perimeter. So good. So we need to find the perimeter here. So how do we find the perimeter of this rectangle? Do we want to draw it? Let's see if we can sketch this thing. Let's see if we can draw a coordinate plane. And if we can sketch this rectangle and see if we can find the perimeter. Maybe we'll have to use the distance formula. Maybe some of the lengths we have here will be vertical and horizontal lines. And so in that case, it might not present a lot of challenge for us. So the first point we have has coordinate 4, 1. 1, 2, 3, 4, 1. Let's call that point A. The second point has coordinate -5, 1. So it's 1, 2, 3, 4, 5, 1. Okay, let's call this point B. The next point coordinate has point -5, -3. So it's -5, 1, 2, 3. So it's -5, 3. Let's call this C. The next point has coordinate 4, -3. So 1, 2, 3, 4, -3. So that's D. Now let's connect these points. Well, we can clearly see that we can clearly find our length here. So we had 1, 2, 3, 4 over here, and we have 1, 2, 3, 4, 5. It should have been 5 right here. So that's basically going to be 9 units. And we had the total distance of up here was what? Just 1 above it. It should have been at 1. So then 1 and then 3 down. So that's going to be what? 4. So the perimeter by rule is given by 2. And I can use this formula, L plus W. So that's going to be 2. Our length here is 9 plus our width is what? 4. So what we have is going to be 2 times 13. So that's going to be 26 units, whatever the unit is. All right, good. Now let's take on problem number 7. So, well, we do not have our diagram yet. All right, good. So we're going to use this diagram here to find the length of SQ. But several things have been provided to us. One, that ST is parallel to what? QR. PS 6 centimeters. ST is 8 centimeters. So basically what we need to do here is to write some ratios here. All right. So let's see if we can do the ratios. So for example, let's see SP. Let's see if we can start by saying the relationship between SP and SQ. So let's see something. Let's do something here. Let's say, look, SP, a short side over there, will be related to this side. This SP will be proportional to what? QP. Will be proportional to what? QP, as ST will be proportional to what? Q, as ST relates to what? QR. Let's try this relationship and see what happens here. So what's the measurement of, do we know the measurement of SP? Yes. SP is equal to, do we have SP? Yes, SP was actually PS written, was the same as that. It's 6. QP. Do we have QP? Do we have QP? Nope, we don't have QP. So we'll make that S, X to be X. Now ST, we have it to be what? 8. And do we have QR? We have QR to be what? 12. So let's solve this relationship. Let's cross multiply. So we're going to multiply 8 by X to have 8X. And 6 times 12 to be 72. So we're going to divide here. And divide here. We're going to have X is going to be equal to what? 9. S is the measurement of basically what? QP. So if QP is 9, if QP is 9, we know that QP is equal to 9. We know that QP is basically equal to what? SQ, which we want to know, plus SP. So if QP is 9, SQ, which we don't know, plus SP, which we know, is 3. We can easily solve here to have SQ to be equal to 9 minus, SP was 6. It's actually 6. So we'll do 9 minus 6 is equal to 3. I kind of was thinking ahead of the answer, so good. So because we know that 3 plus 6 will give us 9, so SQ will be equal to 3. Okay, so let's move now to problem number 8, the last in the series of problems on this section. So I'm going to sketch the circle over here. So as the problem states that we have a circle with center at O and has a chord PR. So that means, for example, we have P and R on the circle. So that's going to be a chord. That chord is 20 centimeters long. And they talk about an angle here. So if the center is at O and they're talking about an angle POR, this is the angle they're talking about. This angle is 120 degrees. And they want us to calculate the radius. Why? What brings together the angle, the radius, and the chord? Let's see. It's arc. Let's see how we can do it. So let's just take this portion of it. Well, let me redraw it so that I can have a very good picture of what we want you to see. So I'm taking this portion of the circle, and this angle is 120 degrees. This side is 20 centimeters long. Well, if I bisected this angle, each of these angles will be 60 degrees. All right, and then this side will also be, in effect, cut into 2 equal pieces. So that's going to be 10. So then, how can I find the length of the remaining side? So let's take this portion now. Let's take this part of this triangle again. This side, this angle is 60 degrees. This side is 10. All right. And what we want to know is to find the radius. The radius is this piece right here. That is the radius right here. That's the radius over here. So how can we find the radius? Well, we know that this triangle is a 30, 60, 90 triangle because we have a 90 degrees here. This is 30. So we can find this many ways. We can use the concept of 30, 60 degrees, 30, 60, 90 triangle and find the measure of this radius. So in this case here, our radius is just going to be, so to find the radius, we need to find the shorter side. So we can either do that, or we just use the simple trigonometric ratios here and say, for example, the sine of 60 degrees is equal to the side opposite 60, which happens to be 10 divided by the hypotenuse, which happens to be R. Put a 1 under here, cross multiply, we have R sine 60 is equals to 10 divided by sine 60 divided by sine 60. We will find our radius to be 10 divided by the sine of 60 degrees. Let's see what we get using our calculator. 10 divided by the sine of 60 degrees will give me approximately 11.54. Thank you very much, and I hope you enjoyed this video.